Hey guys, in the last video we focused on what happens when the vertex was on the circle, but in this video I want to focus when the vertex is literally inside the circle. Okay, so, and I don't mean the center of the circle, right? We know that one. If you've got an angle coming off the center, that's exactly the same as the arc. We've learned that before. The central angle matches the arc. I'm talking like you've got an angle just somewhere else randomly inside the circle. We're talking something like this angle. So the vertex is just somewhere inside, not on, right? We did that one before, and not the center, but just somewhere inside. Well, I'm going to show you what it actually is, and then I'll show you why it is what it is. So the key for this one is the half still comes into play, but in a slightly different way. The measure of angle BAC is actually going to be 1/2 the measure of arc BC plus the measure of arc DE. So it's basically the average of the two arcs. And I use both arcs because technically, if you're looking at angle BAC, aren't you also looking at angle DAE? Right? Aren't those vertical angles? So it doesn't matter which one you're focused on, but both of them should be the same. But these two arcs aren't the same. If these two arcs were the same, this vertex would have been in the middle. So these two arcs are different. We need to find a way to get this angle to match, or to be relatable to those arcs. And the relationship is this. It's exactly half the sum of the two arcs that it hits. The one the actual angle hits itself, and the one that its vertical angle actually hits. Okay? Let me show you why that works. Check this out. I'm going to make this triangle here. I'm gonna use a different color actually. We'll use red. I'm gonna make this triangle right here. Let's pretend that hit. Let's just pretend that hit. That's a triangle. Okay? So we have triangle ACE. Let's call this arc, just X degrees, and this arc Y degrees. Focus your eyes really closely on this angle here, right? Focus your eyes on this angle right here. Can you see how the angle hits the arc that's labeled X, so arc BC? Look right here, look at my hands. This angle hits this arc right here, okay? So if this angle is, this measure is X, what would the measure of this angle be where the vertex is on the circle? Right? Isn't that an inscribed angle? So if this is X, this would have to be 1/2 X, right? Because it takes two of these to make one of those. Cut this in half and you'll get your inscribed angle. Well, follow the logic for where the Y is, right? Look at angle C here. Angle C hits arc DE, which is Y. So if that's Y, this has got to be 1/2 Y. So this is 1/2 X, this is 1/2 X, this is 1/2 Y. Look at this angle here. Let's call this, let's just call it angle 1, just to make it a little easier. Angle 1, if you look carefully, if you look at the triangle, angle 1 is an exterior angle. We learned a long time ago, like chapter 2 or something, I don't remember, maybe 3, where angle 1, where you have an exterior angle, is actually equal to the sum of the two interior angles that it's not next to, that it's not adjacent to. So the measure of angle 1 is actually 1/2 X plus 1/2 Y. 1/2 X plus 1/2 Y. Well, pull out the 1/2, and you have X plus Y, which is exactly the two arcs, which is exactly the formula we have here. So all this is sort of a shortcut of using inscribed angles with a little bit of old-fashioned exterior angle theorem, and you get yourself the same formula that I gave you at the beginning. All right, so bottom line, you need to know this, but if you're curious as to why, this is why. All right, what good is this if we don't actually solve, some problems? So let's actually solve a couple, or one at least, and see how it goes. So let's say you have a picture that looks like this. Again, you recognize the vertex is in the circle. This is what they're telling you to solve for, and they give you this is 30 degrees, and this is 50 degrees. Well, if we apply our new rule, where the vertex is inside the circle, I know that the angle I'm looking for is always half of the two arcs combined. So the two arcs combined are the arcs that it hits. So it's hitting this arc here, it's hitting this arc, and its vertical angle is hitting this arc. Those are the two you're looking at. Like, I don't need these two. If I wanted these two, I'd be looking for this angle instead. So it doesn't really matter which one you're going for, just pick something and stick with it. So X has got to be 1/2 30 plus 50. 1/2 times 80, which is 40. So this angle has to be 40, which means its vertical angle would have to be 40, and then I can go from there and do whatever it asks me to do. But the key is this. The key is this right here. The angle is half the measure of the two arcs added together, the sum of the two arcs that it hits. So angle 1 is half of x and y, and that's basically the inside theorem. Okay, good luck with those, and I'll make one more video for when the vertex is outside the circle. Okay?